Hello, my name is Daphne Braga Anatutong, student ID 2021-834-784. We are from Group 5, 682. We will represent our poster, which is about sustainable water system for Kampung Orang Asli. The introduction is study proper sustainable water treatment plant and sewage treatment plant designed for Kampung Orang Asli using untreated river as the source. The design is based on water demand of 180 liter per person per day and wastewater generation of 80% of water use. The proper system ensures safe drinking water, effective wastewater treatment, environmental protection and compliance with DOE, SPAN, WHO, MS standard. The background study is proposed project at Kampung Orang Asli, Kuala Lumpur. The population is 600% and raw water source at Sungai Mansan. Digital tools, Google Earth and Google Maps, and the topography, forested and hilly terrain. For the existing problem, surface runoff increased turbidity, suspended solid, and organic matter entering the river. Sustainability improvement. Install solar photovoltaic panels, implement rainwater harvesting, use low sand filtration with chlorination, install automatic water quality sensors, add a constructed wetland or stabilization pond, and promote community education and participation.
Hi, my name is Nurhanis Izzati binti Zalani and my student ID is 20233678859. Without further ado, I will explain the water demand calculation. The estimated population is 500 people based on 100 houses with an average of 5 people per house. Using a standard water demand of 180 liters per person per day, the total average water demand is 19 cubic meter per day. After applying the peak demand factor, the peak daily demand is 135 cubic meter per day, while the estimated wastewater generation is 72 cubic meter per day. This value are used to determine the design capacity of the proposed water supply and wastewater treatment system. Next is the regulatory compliance. The proposed system complies with the relevant national and international regulation. It's follow the Department of Environment DOE standard for wastewater discharge, SPAN requirements for water supply services, Malaysian standard MS 1228 and MS 1229, as well as the World Health Organization or WHO drinking water guidelines. Compliance with this standard ensures safe drinking water, proper wastewater treatment, and protection of the surrounding environment. Next, let's look at the engineering challenges. The main challenges include the remote location, which limit accessibility and infrastructure development. The water sources may also experience seasonal variation in both quality and quantity. In addition, regular operation and maintenance are required to ensure long-term system performance. Budget constraint must also be considered because the proposed system should remain affordable for the community. Finally, the design must minimize environmental impact while maintaining a sustainable and reliable water supply system. Moving on to the sustainability evaluation. The proposed system was evaluated based on three sustainability aspects. From the environmental aspect, the system promotes efficient water resource utilization, protect river water quality, reduce pollutant discharge, and ensure proper wastewater treatment. This ensure help prevent the surrounding ecosystem and reduce environmental pollution. From the social aspect, the system provides safe and reliable drinking water, improve public health and sanitation services, and enhance the overall well-being of the Orang Asli community. From the economic aspect, the proposed system is cost-effective, requires minimal maintenance, provide long-term operational reliability, and is suitable for rural communities with limited financial resources. Lastly, the environmental impact. The proposed system provides several positive impacts, including better water quality, ecosystem protection, resource conservation, lower carbon footprint, and sustainability sludge management. However, if the system is not properly managed, there are also potential negative impacts, such as untreated effluent discharge, odor generation, chemical usage, improper sludge disposal, and high energy consumption. To minimize this impact, several mitigation measures are proposed, including regular operation and maintenance, continuous water quality monitoring, the use of eco-friendly chemical, safe sludge treatment and reuse, energy-efficient technologies, and community awareness programs. And moreover, the proposed water supply and wastewater management system provide a practical, sustainable, and environmentally responsible solution. It ensures a safe water supply, effective wastewater treatment, and improve the quality of life of Kampung Orang Asli community while protecting the environment of future generation.
Hello, my name is Wan Amirul Hazid bin Wanswai. Matric number 2022-835492. And I will be presenting the proposed water treatment plan designed for the sustainable water system for Kampung Orang Asli at Kuala Lumpur. So as you can see, the schematic flow diagram summarizes the complete treatment process. The raw river water first passes through the intake screen, followed by coagulation and flocculation, sedimentation, rapid sand filtration, chlorination, and finally enters the clean water storage tank before being distributed to the community. The entire treatment system is designed to maximize the gravity flow, making it suitable for remote rural areas with limited electricity. So as you can see, the first unit is the intake structure and core screen. Its main purpose is to remove large debris such as branches, leaves, plastics, and floating materials from the river water before entering the treatment process. This will protect the downstream unit and prevents any blockage within the treatment system. The second stage is coagulation and flocculation. Here, aluminum sulfate will be added as the coagulant. Then rapid mixing distributes the chemical evenly, while slowing mixing will allow the fine suspended particle to combine and form larger flocks. These larger flocks can then be removed much more efficiently during sedimentation. Following is the sedimentation tank. This unit allows the heavy flocks formed earlier to settle naturally by gravity. Based on our engineering calculation, the required tank volume will be 28.13 cubic meters with surface area of 11.25 square meters, and the proposed dimension is approximately 5.7 meters long, 2 meters wide, and 2.5 meters deep. The detention time is about 3 hours, which will provide sufficient time for effective settling. The clarified water will then flow into two rapid sand filter unit. So this filter will remove the remaining fine suspended solid and significantly reduce turbidity before disinfection. We selected two filter units instead of one because of one filter can continue operating while the other undergoes maintenance, improving the reliability of the overall treatment system. So the next process is chlorination and disinfection. A controlled chlorine dose is applied to eliminate the harmful bacteria, viruses, and other pathogens. In addition, chlorine will provide residual protection throughout the distribution system, ensuring the water remains safe until it reaches to the consumers. Finally, the treated water will be stored inside a 100 cubic meter elevated water storage tank. The storage capacity is enough for 1 day's average water demand, ensuring a continuous water supply even during peak usage. Because the storage tank is elevated, the water will be distributed to the village using gravity, eliminating the need for electrical pump. Based on the treatment sequence, we expect a significant improvement in water quality. Initially, the raw water contain relatively high concentration of biochemical oxygen demand (BOD) and total suspended solid (TSS). So after the sedimentation, these values will decrease substantially. Following the rapid sand filtration, the remaining suspended solid will be further removed. Finally, after the chlorination, the treated water will achieve a BOD less than 20 milligram per liter, TSS of less than 20 milligram per liter, and maintains a suitable pH range between 6 and 9. This is complied with the Department of Environment discharge standard while also producing safe drinking water. So in conclusion, our proposed water treatment plant combines a conventional treatment process with a gravity-fed distribution system to provide more sustainable and reliable water supply for the Kampong Orang Asli community. This design is technically feasible, energy efficient, easy to maintain, and suitable for remote rural areas with limited infrastructure. That's all from me. Thank you.
Hello, my name is Muhammad Daniel Ashraf. My ID number 2020827852. I will present about the sewage treatment plant (STP), which focus to what type of design STP and to explain the STP process flow. The type of STP that we use, which is waste stabilization pond. This type is more suitable wastewater treatment technology for Kampong Orang Asli, which located at a small rural community with limited electricity supply. Besides, this technology offers low construction and operational costs, which requires minimal maintenance and consume very little energy. This STP design also rely mainly on natural biological process, algae, bacteria, and sunlight instead of mechanical aerators, which making them ideal for the rural communities. So for the STP process flow, the system consists of a bar screen, grid chamber, primary sedimentation tank, facultative pond, maturation pond, and chlorination unit before it released to the river as a treated wastewater. At the bar screen, raw sewage from the collector sewer enters the bar screen and passes through the parallel steel bars. The function for the bar screen is to remove plastic, paper, clothes, branches, and other large debris. After screening, it flows to the grid chamber. In that line, the flow velocity will reduce to allow heavier inorganic particles settle to the bottom, while lighter organic remains suspended. Its function is to remove sand, gravel, and reduce sludge accumulation in ponds. Next, the wastewater passes through a partial flume, where the flow rate continuously monitored. It measures influent wastewater flows and help to determine treatment efficiency. After that, it enters the primary sedimentation tank. and remain for approximately 2 hours. During the detention period, suspended solid settles to the bottom and form sludge, while lighter materials float to the surface and form scum. Both sludge and scum removed periodically. The removal efficiency for the BOD will approximately about 25 to 40%, and for the total suspended solid, which is 50 to 70%. The partially treated wastewater flows into the facultative pond, where natural biological treatment occurs approximately 20 days. This pond consists of the three biological zones, which is upper layer or anaerobic zone, middle layer or facultative zone, and bottom layer or anaerobic zone. This can remove dissolved organic matter and suspended solids and significantly reduce BOD. So for the removal efficiency for the BOD, which is to 70 to 90%, and for the total suspended solid, which is 70 to 85%. Then, the effluent from the facultative pond will enter the maturation pond and remains for the 5 days. During this period, exposure to the sunlight, natural sedimentation, and biological activity further improves the water quality. Before discharge, chlorine is added to the treated wastewater and remains contact time for 30 minutes, which allowing sufficient time for effective disinfection. After after chlorination, the treated wastewater discharged into the nearby river through the outlet structure. The final effluent is expected to meet the Malaysia DOE Standard B discharge requirement for the domestic sewage and minimizing pollution of the receiving water body. Besides, it's expected to support and sustainable wastewater management for the rural community. That's all for me. Thank you.
Sustainability Development Goals. There are 4 SDG, which are SDG 6, Clean Water and Sanitation, SDG 14, Life Below Water, SDG 3, Good Health and Wellbeing, SDG 13, Climate Action. For practical feasibility, we have technical, financial, operational, community, and environmental feasibility. The conclusion is the proposed WTP and STP for Kampung Kuala Asli both are designed to provide a sustainability and reliable water sanitation solution for 500 residents. The system meets the estimated water demand of 90 MQ per day with a peak demand of 135 MQ per day and include suitable treatment processes to produce safe drinking water and according to Malaysia and Spain guideline. The selected waste stabilization, consumption, minimum maintenance, and cost-effective operation improve public health and protect water resources and support SDG and also provide a feasible long-term solution for the community. That's all from our group. Thank you.